Hello y'all. In this video we're going to be talking about exercises 7.6 and 7.7, which all involve the same argument, the 7.6 and 7.7. It's just the 4 steps of doing the Venn diagram method have been sort of split it up. But anyway, put them both together and you have the entirety of the Venn diagram method. So I'm going to quickly go through these 10 examples and show you how to do this. Alright, here's example number 1. We've got our 3 premises. We have a universal and 2 particulars. So first step is always to identify the terms. So S is the subject of the conclusion. It's going to be plants. P is going to be the predicate of the conclusion, that's apples, and then vegetables is the middle term, it's the leftover term. Okay, so step 2 is just to rewrite the argument with our terms. So no P, R, M, that's the universal. The particular is some. See plants here, some SRM, and the conclusion is some SR not P. So there you go. The third step is to draw a picture of the 2 premises. So in this case we have a universal negative and a particular affirmative. So universal negative is shaded in football. A particular affirmative is an X in a football, and you always do the universals first. So no P or M means that this area would be empty, right? That's what shading means. And then the particular affirmative is saying that there's at least one thing that's both. So that's with the X, and so there's something that is both an S and an M. So that's in this football on the left, and half of it is shaded in, so it just goes in the spot that isn't shaded. Okay, so final step, is this argument valid? Well, we look at the conclusion. The conclusion says some S are not P. So what that means is that you're looking for an X that is in the S circle but outside of the P circle, and we have one. So that X is in the S circle. It is an S, but it's not in the P circle, so it's not a P. So drawing a picture of the premises has given us a picture of the conclusion. So this argument is valid. Okay, example number 2. Here's a situation where everything is a universal, so all horses are mammals, no mammals are lizards, therefore no lizards are horses. The subject of the conclusion here is lizards. The predicate of the conclusion is horses. And mammals is the middle term. So not M for mammals, but M for middle term. Okay, if you rewrite this, you're going to get all P are M. You're going to get no M R S. And you'll get no, for the conclusion, no S R P. Alright, so here's a situation where everything you do involves shading, so it doesn't matter which one you do first. So we'll just go in order here. So all P or M is a universal affirmative, so that means that everything in the P circle is also in the M circle, so that means this part of the P circle is empty. There's nothing that is outside of the M circle has any members. So this area, this crescent shape area, would be empty. So that's premise one. Premise two is no M or S, so that means there's nothing that is both an M and an S, and so that means the overlap between M and S is empty, and that's what that looks like. And then finally, once we have the two premises written, the next step is to excuse me, to check and see whether or not you have a picture of the conclusion. So in this case, we do. The conclusion is no S or P. That means there would be nothing that is both an S and P, and that would mean that the overlap between S and P has been shaded out. And if you look at our picture, that yes, indeed, the overlap has been shaded out. So this argument is valid. Drawing a picture of the premises has given us a picture of the conclusion. All right, example number 3. We have another situation where everything is a universal. In this case, we have all cars are self-propelled vehicles, all motorcycles are self-propelled cars, therefore all motorcycles are cars. You should see kind of right away here that this argument is probably not going to be valid, given that those premises are true and that the conclusion is false. But nevertheless, our S would be the subject of the conclusion, motorcycles. Our P is going to be cars. They're just the predicate of the conclusion, and then self-propelled vehicles is going to be the middle term. Okay, so we rewrite everything. We get all P R M, all S R M, therefore all S R P. Okay, so again, everything involves shading, so it doesn't matter which one you do first, so we'll just go in order. Both of these premises are universal affirmatives, so it involves shading in a crescent shape. So here's all PRM, so this area down here would be empty. And then the second premise is all SRM. So that's this crescent over here. And you'll see that part of that crescent has already been shaded in. So it'd be a little bit of overlap, or you could just stop, doesn't really matter. Empty is empty. But that shading, actually, or that overlap tells you a little bit something about the validity of this argument, which is that this argument is not going to be valid. So the conclusion here is all S or P. And what that means is if you had that picture, then another crescent would be shaded in. The S crescent with respect to the P circle. But if you look over here on the left, we see that part of that crescent has been shaded in, but part of it is not. I'll circle it here. This area would need to be shaded in too in order for to have a picture of the conclusion. So we don't have a picture of the conclusion, and thus the argument is invalid. So moving on, example number 4. Some roses are yellow flowers, all roses are plants, therefore some plants are yellow flowers. So universal to particulars. Let's talk about our terms here. So subject of the conclusion is plants. Predicate of the conclusion is yellow flowers. And the middle term is roses. So we've got that, and we've got our two or our step 2, which is where we rewrite the argument. So we've got all MRP, some MRP, and then all MRS, therefore some SRP. So drawing this picture, this is a situation where you remember you have to do the universal first, so that's actually the second premise. So the universal here is a universal affirmative. That means you shade in this area, and then the second premise, or the other premise, is a particular affirmative. So some MRP, that would mean that there's an X and this M and P overlap, and some of it has been shaded in, but some of it's still open. So the X goes there. And now we check. So do we have an S that's a P? So do we have at least, do we have an X in the S and P overlap? And we do have an X there, so this argument is valid. Alright, here's example number 5. We have all roads are highways to Rome. No mere paths are roads. Therefore, no mere paths are highways to Rome. So here is another situation where everything is universal. So first thing is to identify our the subject of our conclusion is mere paths. The predicate is highways to Rome. And that leaves roads as our middle term. So if we rewrite the argument, we've got all M are, let's see, highways to Rome is P, so all M are P. We've got no S R P, therefore no SRM, and therefore so no SRP. Okay, so drawing these two premises, doesn't matter which one we do first because they're both universals. So I'll just go in order. So all MRP is a universal affirmative. That means you shade in a crescent shape here. So in this case, we're pushing all the M's into the P circle. So there you go, all M or P. And then no SRM is the overlap between S and M. So that area is empty too. So again, sort of our shading sort of overlaps, and that's okay, but that is going to mean that this argument is not valid, because the conclusion is no S or P, and in order for that to be right, you'd have to have the entire S and P overlap sort of shaded, and part of it is, but part of it is not. So notice the circle here, that would need to be shaded. So not shaded, that means the argument is invalid. Alright, example number 6, we have some videotapes are not film classics, all black and white movies are film classics, therefore some black and white movies are not videotapes. So subject of the conclusion here is black and white movies. Predicate is videotapes, and that leaves the middle term as sort of film classics. So rewriting the argument, we've got some P are not M. All S are M. Therefore, some S are not P. So we've got a couple universal, one universal affirmative and then a couple universal negatives. So if you do the premises, in this case we have to do our universal first, which is all S are M. So that's a universal affirmative. That means we're pushing all the S into the M circle. So this area, this crescent here is empty. And then for the other premise, some P are not M, that would be a P that isn't an M, so you would have at least one X that's in the P crescent with respect to the M circle. So in the P circle, outside of the M circle, there are two possible areas, but one of them is shaded in, so it goes there. So that leaves us then with the conclusion. Do we have a picture of the conclusion? Some S are not P, so we'd be looking for an X that's in the S circle, but not in the P circle. And we have the opposite situation here. We have an X in the P circle, but not in the S circle. But that's not what we want. We want something in the S circle and not in the P circle. So that means this argument is not valid. And we move on. Okay, example number 7. All presidents are leaders. Some statesmen are not presidents. Therefore, some statesmen are not leaders. So subject to the conclusion here is statesman. Predicate is leaders. And that leaves presidents as the middle term. So, sorry, that was my cat. So we rewrite the argument and we get all M are P, some S are not M, therefore some S are not P. So here we have our Venn diagram. So we do our universal first, which is a universal affirmative. So all M are P, so we're pushing all the M's into the P circle. And then our our particular negative is some S are not M. So here's an interesting sort of situation that I'll kind of pause here sort of to talk about. So up until now, when we were putting X's in things, we've always had sort of half of the area sort of shaded in. But sometimes you're in a situation like this where the X goes is both areas are open. So let me just kind of note here with a different color that when we go to put the X in for this the second premise here, it would go somewhere in this crescent shape, right? So it's an S that isn't an M. Both of those areas would count, right? It would be in the S circle, but not in the M circle. So either there or there. So when you're faced with a choice, given that you only have sort of one X, you have to put the X on the line between those two areas to indicate sort of your indecision, that you're just not sure. It could go in the area on the left, could go in the area on the right. You just don't know. So in situations when that happens, your argument, whatever the conclusion is going to end up being invalid. So that's because the x could be in the right spot, but it could also not be in the right spot. So in this case, some s are not p. We have a situation where the x is on the line, and what that means is, as I said, it could be in this area on the left, which would be an s that isn't a p, yes, but it could be in the area on the right, which is not an s that is not a p. So in this situation, because of that indecision, because we don't know for sure, we have to say that the argument is invalid. So just to kind of reiterate, anytime that happens, anytime that you're faced with a situation where you have to put the x on the line, the argument will be invalid. Okay, example number 8 here. All politicians are campaigners, all campaigners are money grubbers. Therefore, all politicians are money grubbers. This is a situation that we've actually seen before. This is what's called the Barbara argument. And here we have our subject is politicians. Our predicate is money grubbers. And again, when I say this, it's of the conclusion. So subject, predicate of the conclusion. And that leaves campaigners as our middle term. So again, the term that's in both of the premises but not in that conclusion. So you rewrite this, you get all SRM all MRP, therefore all SRP. So you rewrite this, excuse me, now that it's rewritten, we can do our shading, because everything is shading here, so we have all SRM. So push all the S's into the M's, so this area would be empty. And then push all the M's into the P's, that would make this area empty. And then you're done. So we got these two areas shaded in. Now, do we have a picture of the conclusion? Yes, we do. So the conclusion is all S or P. So we have a situation where the S crescent with respect to the P circle has been sort of shaded in. So all the S's have been pushed into the P's. In fact, they've all been pushed right into the middle there. So all S are in fact P, and they're also all M. So a little bit of extra information, but nevertheless, what that means is that the argument is valid. All right, number 9, no elm trees are cacti. Some tall plants are elm trees, therefore some tall plants are not cacti. So tall plants is our S, subject to the conclusion. Cacti is our P. And elm trees is our M. So we rewrite this to no MRP, some SRM, therefore some S are not B. All right, so here's a situation where we have a universal and a particular, so we do a universal first. No M or P, so the overlap between M and P is empty. And some S or M is there's at least one thing that is both an S and an M. So we got an X in a football, and it has to go on the left here. Can't go in the middle because the middle is empty. So does that give us a picture of the conclusion? Yes, it does. The conclusion is some S are not P. So you would need an X that's in the S circle, but not in the P circle. And we have that, so this argument is valid. All right, the last example here from exercise 7.6 and 7.7 is another situation where everything is a universal affirmative, but this arrangement of universal affirmatives is actually not valid. So we have the subject of our conclusion here is dangers to society. Sorry, dangers. The predicate of the conclusion is criminals. And then thieves is our middle term. So you rewrite that, you get all M are P. And all M are S. And there you get, as a conclusion, all S are P. So here we got two universal affirmatives, and they all involve sort of shading areas in the M circle, right? So you got to push all the M's into the P's. So that would look like that. But you also have to push all M's into the S's. So that would leave this area empty. So the only area left open is down here in the middle, right? So if you're an M, you're both an S and a P. But that's not what the conclusion is saying. The conclusion is saying some S or P. So if that were true, then we would have pushed all the S into the P circle. But you'll notice that this area is still pretty wide open. And so that is not a picture of the conclusion, right? The conclusion is all S or P, and so we don't have a picture of that. And that means that the argument is thus invalid.